Well, hello. If you are not in Allen High School taking AP Chemistry with me, I want to welcome you and join us. We are discussing reactions at this point, predicting and writing chemical reactions. And our next chemical reaction is a more unique one. You've not seen this before, likely. You may have, depending on your school, but here at Allen, we don't cover coordination compounds and the formation of complex ions. Now, how we recognize these is by noting the type of substance that are our reactants. You're going to have a transition metal, and it's typically going to be a transition metal ion or maybe aluminum with ammonia, hydroxide, or cyanide, or a variety of others. But here's the key with that variety of others. We take the metal ion, so let me explain these terms in the context of this example. I have a copper 2 ion, so copper 2 plus ion, and I'm going to react it with ammonia. I want to write out the structural formula of ammonia. And you'll note that if you do that, you see this non-bonded pair of electrons. So this is electron rich, and this is electron deficient. It's a positive ion. And so there's going to be a force of attraction. And that's what a complex ion is. That's what a coordinate bond is. A coordinate covalent bond is when one of the substances contributes both electrons to form the bond. Now, copper happens to like 4 of these. It's very electron deficient. And so I'd have my copper, and I'm going to complex form a compound with 4 ammonias. And there would be something in the question that would guide you to that number. Now, since copper's plus 2 and ammonia is 0, that means I have an ion, a 2 plus ion. So that's called a complex ion. The electron-rich substance is called a ligand. That's some vocab. You should familiarize yourself with that vocab. Now, you can't go to the stock room and get a jar with ions. We have to have a neutral substance. So a complex would take that charged ion, it could be a cation, it could be an anion, and provide a counter ion. So in this case, I need a counter ion. So I'm going to put 2 nitrates. So this would be the coordination complex, and this would be my complex ion. And that's how you would draw those. Hydroxide has many non-bonded electrons associated with it, as does cyanide. Cyanide is Cn minus, is a common one. Sometimes you'll see chloride as an example of a ligand or an electron-rich substance. So let's try another example. And here, I give you a little bit more information. We want to write the net ionic. This time we have a net ionic to deal with. The formation of, so that means it's my product. I have aluminum. We're not going to get into naming these, but if aluminum's plus 3 and hydroxide's minus 1, this is a complex anion, 3 negative, as shown in the problem. Now I'm going to form this from potassium hydroxide plus solid aluminum hydroxide. Aluminum's plus 3, hydroxide's minus 1. So if I made this solid, that's what it would be. So if I pour this solution onto this, I would get this complex ion. So let's dissociate these. I get K plus. I'm going to balance these at the end. I don't know why. They just seem a little easier to balance at the end for me. So I'd have aluminum. Here I'd have leftover potassium, wouldn't I? So I'm going to have aluminum hydroxide. And then I'm going to make my complex ion. Do you notice I put square brackets around that? And then the charge, that's the common notation. We see here that potassium's our spectator ion. So really all we need is a source of hydroxide plus aluminum hydroxide, and I would get that desired complex ion. Now, most of the time, these are not redox. If your reactant is a pure metal, like this reaction with aluminum plus hydroxide, then it would be a redox. But by and large, complex ions are not redox. So if you're in doubt, assign oxidation numbers. Right? That's the generality for that one. Okay, kiddos, see you in class, because you are always my best chemistry students.